4.4. Use your knowledge of directional selection to explain the results shown in Table 3. So, directional selection is when the mode of natural selection in which an extreme phenotype is favoured over other phenotypes, causing the allele frequency to shift over time in the direction of that phenotype. So if we look back at Table 3, we can see that as the breeding cycles continued, then the number of plants that did not produce the 2N gametes started to reduce, and then after 3 breeding cycles went down to 0, and the number of plants that did produce the 2N gametes started to increase until it was all of the population. It tells us earlier on in the question that the scientists investigated the possibility of breeding red clover plants that only produced the 2N gametes. So in terms of describing directional selection to explain these results, we know that the scientists actually selected those individuals that were producing the 2N gametes. So there was selective breeding going on, or there was artificial selection of those plants that produced the 2N gametes. So therefore, these plants passed on their alleles, and that allele was for the production of the 2N gametes to the next generation, but you only need to state that their alleles were then passed on. Therefore, the frequency of the alleles for the production of 2N gametes will have increased in the population. You can also gain a mark if you have the converse of the answer. So you've talked about it in terms of the plants that did not produce the 2N gametes, because these were selected against. So therefore their alleles were not passed on to the next generation, and the frequency of these alleles then started to reduce. They will not accept number instead of frequency. So for marking point 3, you do need to make reference to the frequency of alleles for production of the 2N gametes increasing, not just the number of the alleles.